about molarity today. Molarity means it's the amount of solute dissolved into like a particular volume of a solution, right? So you're basically talking about concentration. We've been talking about solutions a lot, right? So what does concentration actually mean?
So whenever I think of concentration, I think of how much of stuff we've put into our solvent. So if I have like water, how much sugar have I put in there?
Yes, that's right. So let's go ahead and just write out the definition for molarity, like in those terms, right? Molarity is the amount of solute in moles over this particular volume of solution. So it's talking about concentration. Molarity is equal to concentration of a solution. And concentration is, like you said, it's how much stuff is dissolved into your solution. So how much solute dissolved in solution in a solvent, right?
Yeah, solvent. So it's like you have some tea, you put a little bit of sugar in there, it's kind of sweet. You put more sugar in there, it's a higher concentration, it's even sweeter.
Yeah, if you dissolve more stuff, you're going to have a higher concentration. That's right.
That's what I think of.
So these are kind of written in formula form, but I wanted to write it out just a little bit better, just to make it more clear. So molarity we write as an M. Molarity is an M, and it is equal to moles, so N over V, right? So N is moles, that's what N is over there, and V is our volume, and then molarity is M. And so to do this, we're going to have to kind of bring back train tracks just a tiny bit, because sometimes you're going to see mass instead of moles, or you're going to see moles and the problem is going to ask for mass. And so it's really important to remember how you find moles, that it is your mass divided by the molar mass, right? Moles are equal to your mass in grams divided by molar mass. Okay, and we're going to see that come up a lot in these problems. So I know it's kind of just like a drag to bring back train tracks, but you know it's good to practice them to get really good at them.
And most of the time when you see the molarity, you'll also see like mole written out. So if they see that too, it's the same thing.
Yeah, N is the same thing as moles, right? So let's start with a couple of practice problems. And it wants us, it says find the molarity of a solution made by dissolving 0.335 moles of ammonium sulfate in, and there's a formula for ammonium sulfate, NH4,2SO4, in 600 milliliters of a solution. So we're going to write out the variables that they gave us, right? We know we're going to be using this formula because it said that, right? We're finding molarity, which is equal to N over V, right? And then how many moles do we have?
We have 0.335 moles.
That's right. They gave us moles in the problem, and we have 0.335 of them, right? And what else did they give us in the problem?
They also gave us our milliliters of solution, so our volume. And they gave it to us as 600 milliliters.
Right.
So I think we're going to have to change it.
We are, because volume has to be in liters. So before we can do anything else with it, we got to move these decimal places over to convert it into liters. So that's actually going to be 0.6 liters. And then it wanted to know molarity. That's the concentration, right? So we just plug in what we have. Molarity is equal to our moles, 0.335 over 0.6. And we're going to calculate that out.
So we have 0.335. divided by 0.6.
Yep.
0.56.
All right. 0.56 moles per liter. That's the units for concentration right there. Well, that wasn't very hard, was it?
Nope, didn't seem that bad.
So let's kick it up a notch then. Let's say that we have liters and we have molarity and we want to know mass. So now we're going to have to solve for moles and convert it to mass. So like I said, we're going to bring those train tracks back. But I mean, it's the really, they're really simple steps, right? It's just a one-step problem. So we have mass, but to get to mass, we have to find moles. So let's start with writing out what we're given. All right, we're going to use the same formula as before. And what did they give us in the problem?
They gave us a molarity of 0.735.
Okay.
And a volume of 0.4 liters.
Okay, moles per liter, right? And a volume. Oh, good. They already gave it to us in liters. And it wants to know moles. It actually wants to know mass, but we have to find moles before we can get to mass. So let's go ahead and set up the problem. We've got 0.735 molarity is equal to N over 0.4. So before we solve this, okay, this is kind of tricky, right? Because we're not really sure sometimes if we have to multiply or divide. So there's a nice trick. We can set this up in a triangle, right, where we put moles down here, molarity down here, moles up there, and then liters right here. So this is our molarity, so that's our 0.735. And then here is our liters, so that goes right here, 0.4. Do you remember how the triangle works?
I think to find the other one, you either have to multiply or divide. And it looks like in this one, we're going to have to multiply.
That's right. If things are across from each other, we multiply. And if they're on top, then we divide. So we're going to multiply 0.735 by 0.4 to find our moles.
And I got 0.29.
Okay, good. 0.29 moles. And we're not quite done yet because we have to go to grams. Right? We need to find mass. So we're going to take our given, which is these moles, and we're going to put it in our train tracks right here. So 0.29 moles of what?
NaNO3.
NaNO3, right? Right here.
Sodium nitrate.
Good. And we're going to put 1 mole of NaNO3 on the bottom, and then the molar mass of NaNO3 on top. So we're going to have to find that grams from the periodic table. So Na,
which we have right here.
right. What's the mass of Na? Do you see it right there?
I do. It's 22.99.
So we're going to, it's 23 grams, right there. So N is 14. And then O is what?
16.
Right, and we got 3 of them, so 16 times 3. So 23 plus 14 plus 16 times 3.
Got 75.
All right, so 75 grams is our molar mass, right? So that's how many grams are in 1 mole of NaNO3. So now we can cancel out the moles, and we'll be left with grams. So 0.29 times 75.
It's going to be 21.75.
All right, so 21.75 grams of NaNO3.
All right.
Very good, yeah. So we just used our molarity formula to find moles, and then just took those moles and multiplied them by the molar mass to find grams, right, which is what it asked for up there. So that was not hard, right?
Not that bad.
Okay, so let's do one more. We want to know what volume in milliliters, of a 3.52 molar solution would contain 45 grams of ammonia. So they gave us grams, but we need moles to find the volume to plug into our molarity formula. So what are we going to have to do with those grams?
We're going to have to do our train tracks, or change them to moles.
All right, so let's do it. So 45 grams of ammonia and H3. So let's go ahead and stick that in our train tracks. And 1 mole of NH3 is going to go on top over the molar mass of ammonia. So let's go ahead and find the mass from the periodic table. So N we know is 14, because we found that already. H is 1 times 3, which is equal to 3. So 14 plus 3.
It's going to be 17.
17 grams. So 17 grams is going to go right there. Okay, so let's cancel out grams, and we'll be left with moles. So it's 45 divided by 17.
2.65.
Okay, cool. So 2.65 moles. All right, so now this is going to go in for our N. We still got to find volume, so we're going to still use our molarity formula. So M is equal to N over V. N is 2.65. What else did they give us in the problem?
They gave us molarity. We have 3.52.
Okay, so that's our concentration, right?
Our concentration in moles per liter.
Right. 3.52 moles per liter. So M is the same thing as moles per liter, by the way, in case you were wondering. And then we're trying to find volume. Okay, so let's go ahead and plug this into our triangle, right? So N goes on top, molarity goes on the bottom, and volume goes on right there. So the 2.65, our moles is on top, over our 3.52. So if they're on top of each other, we're going to divide, right? So 2.65 divided by 3.52 is what?
0.75.
All right, so our volume is 0.75 liters. Now to get it into milliliters, what do we have to do?
Don't we multiply by 1,000?
We
or
do.
Just move the decimal place over 3 times?
That's right. So 0.75, if we move the decimal place over 3 spots, that's going to be the same thing as 750 milliliters right there. Very good. So that is our answer.
Very cool. And ask your teachers if you have any questions.